કેટલા છોકરાને ભણાવે છે કાકા? આટલા બધા
બેગ બે નહીં બેગ.
ચાલો ચાલો કરે હવે આપણે ધીમે ધીમે છે ને બહાર
પછી હું તને બહાર એવું કહું ને હે ને દરવાજો બંધ કરી દે ત્યારે કેવું કહેવાનું? તું કરતો ખરો જ હું દાદાને આપણે દેખાડીએ બાય કે રીતે કહેવાય
કે તે કહેવાય ભાઈ આમ આમ કહેવાય ભાઈ
એવું કેવાનું? चलो 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 बाबू चलो હવે બહાર જાઓ. કાર ચાલે છે હવે હવે બંધ કરીને બહાર જતો બાબુ પછી બાય કઈ આજે ખબર નહીં જતો નથી.
આના બધું લઈ લે છે આપણે બધું લઈ લઈએ.
Good morning, everyone. So let's start. We are now going to solve the example 4.3 from the textbook. Okay. Okay, so here is the question. A motorboat is racing towards north at 25 km per hour, and the water current in that region is 10 km per hour in the direction 60° east of south. Okay. So here it is that we are given a speed for motorboat, right? We are given a speed for motorboat, right? And the speed is 25 km per hour and it's moving towards north. Okay, and it is moving towards the north. Now, this thing is given with respect to what? That is the first point that we should get clear about. This is a motorboat, right? So motorboat moves in water, right? Motorboat moves in water. So whenever someone specifies speed of a motorboat, that is going to be with respect to water, right? So let's write that. It is given that velocity of boat with respect to water, right, is given to be 25 kilometer per hour in north direction. Okay, I'm just writing the direction in brackets so that it's a vector. Don't forget, we are dealing with two dimensions here, right? Okay, so first of all, it's important to just draw a rough diagram. So let's say this is the directions. Okay, right? Okay, so where is the velocity of the motorboat with respect to water? It's towards the north. So this is VBW vector. Again, the diagram is the key thing. Diagram થઈ જશે, બધું થઈ જશે, right? Otherwise, it's going to be tough. Then the water current. Water current means flow of water, right? Water current is obviously the flow of water that occurs, right? So here it is given that the water current means flow of water is 10 kilometer per hour in direction 60-degree east of south. So let's write that flow of water means water current VW, but that is with respect to ground, because when we say water is flowing, right, ultimately flowing of water is with respect to ground. When we say a river flows, so that is with respect to ground. Okay, so this VWG is given to be 10 kilometer per hour, and in what direction? In a direction 60-degree east of south. Again, the way to understand 60-degree east of south, you can also replace this word of with from, if you understand it better that way. So 60-degree east from south. So first of all, you face south, and from there you go 60-degree towards east, right? So that would be somewhere here, so that this angle is 60-degree, right? So this is VWG. All right, I hope this is clear, right? So we have made two vectors in our diagram, right? One is VBW and the other is VWG. Now we have to find the resultant velocity of both. So ultimately, it's not very clear in this question which velocity do we have to find. So we have to find velocity of boat, but that would be with respect to ground, because when people take a boat, they want to go from one place to another place, correct? On ground, right? Okay, so I'm sure you understand that boats are used to go from one place on ground to another place on ground, but via water, right? Or through water. So we have to find VBG vector. So this is clearly a case of relative velocity. Okay. All right, everyone. So let's do that. So first of all, we will write the equation of relative velocity. Okay, so that equation gives me VBW vector is equal to VBG vector minus VWG vector, right? This is the famous relative velocity equation, but we want to find this. So we will put the other term on that side. So we get VBG vector is equal to VBW vector plus VWG vector. Okay, so I can say that we will get our answer by adding two vectors. Okay, right. So tell me, what are the two ways to add two vectors when we draw a diagram? What are the two ways to add two vectors when we draw a diagram? After drawing a diagram, you can see here I've drawn two vectors. What are the two ways to add vectors in a diagram? There are two methods to add, right? What are the two methods to add? Come on, people, I'm waiting for your answer. Most of you are telling me only one method. What are the two methods? I'm making it very clear. What are the two methods to add? I'm talking about diagrams, okay? By components, of course, you can do that. I head to tail method શું છે નંદિની એવી ક્યાં કોઈ method છે? Okay, the two methods are triangle law of addition or parallelogram law of addition, right? You could use either of these two. Okay, so we'll have to use either this or that. વેક્ટરમાં આવ્યું હતું ને શું આવ્યું હતું? એને હેડ ટુ ટેલ નો કહેવાય ને. અરે બધાને કહું છું રિવાઇઝ કરો થોડું વાંચો, બધું ભૂલાતું જાય છે. Okay, see, let me just make one thing very clear. In online education, all the responsibility is transferred to your shoulders. હું કઈ તમારા ઘરે આવીને તમને જરાક વઢી ન શકું, તમને કહી ન શકું કે એ તું વાંચતો કેમ નથી, right? In school I would share that burden and we can do much better. So I hope you realize that as far as discipline is concerned, you are on your own. તમે રોજ વાંચો તો વાંચો, ન વાંચો તો એ તમારી ઉપર છે, પછી છેલ્લે તમને નહીં આવડે. I cannot do anything here. હું અહીંથી કઈ તમને વઢી તો ન શકું ને ઓનલાઈન ક્લાસીસમાં. એવું તો ન કહેવાય આટલું આ વાંચ્યું નહીં, ચલો 3 વાર લખીને આવજે, તો શું ફરક પડે? So everyone, please take part of that responsibility. અને બહુ ક્લિયરલી કહું છું, જે રિસ્પોન્સિબિલિટી નહીં લઈ શકે એના માર્ક્સમાં ડ્રાસ્ટિક ડિક્રીઝ આવશે. 10th ના અડધા થઈ જાય તો ના નહીં. ઓકે, ભલે પેપર બધું ઈઝી જ હોય તોય તે. So please be very careful. Okay, this year is exceptional. હાફ તો નોર્મલ છે ફલક, હાફ ઇઝ વેરી નોર્મલ. ફિઝિક્સમાં અહીંયા ભલભલાના હાફ થઈ જતા હતા ક્લાસરૂમમાં. તે આ ઘણા કઈ તમારા માઇન્ડમાં એવી ઇમ્પ્રેશન નથી થઈ ગઈ ને કે મેં તમને કીધું કે મારે 3 out of 20 આવ્યા હતા, તો સર તો સાવ ઠોઠ હશે. હે, યુ હેવ નો આઈડિયા. હા, એટલે તમે એવા વહેમમાં ન રહેતા. So please be warned in time. રોજ મહેનત કરતા રહેજો, નહીતર છે ને પ્રોબ્લેમ પડશે. એટલે જૂનું ફિઝિક્સમાં છે ને બધું કન્ટિન્યુટી છે. હું તમને કહું છું, ચેપ્ટર્સ 2 to 6 ત્યાં સુધી પીછો નહીં છોડે જ્યાં સુધી ફિઝિક્સ ભણશો. આ ચેપ્ટરની એક વસ્તુ વારે ઘડી આવશે. લેટ મી બી વેરી ક્લિયર અબાઉટ ઇટ. Okay, so please everyone revise things. Okay, so here we have to add these two vectors, but the way I have drawn them, you see I've drawn them by common tail. So we should use parallelogram law, not triangle law, to add. Okay, so if I do that, I'll just do it here again. એટલે આમ થોડો clear diagram દેખાય. Okay, it's something like this. right? આ વેક્ટર actually નાનો છે, આ વેક્ટર મોટો છે થોડો, because this is 25, no sorry, this is 5, yeah, 25 and this is 10. So now if I complete the parallelogram, it will look like this. Okay, so the final velocity that we get by addition is as follows. Right, now let's put labels so we know what we are talking about. This is VBW, that is velocity of boat with respect to water. This is VWG, that is velocity of water with respect to ground. And this red arrow, which is resultant, is the velocity of boat with respect to ground. So now this is what we have to find. So first of all, you see here you can do it by components. Okay, it's not wrong. You can do it by components also, and you can do it by resultant magnitude. So let's do it by resultant magnitude. કારણ કે last time તમને બધાને easy લાગ્યું હતું એવું મને યાદ છે. Okay, so we can just do it by resultant magnitude formula. Okay, I don't think I need to explain most of this here. બરાબર, ફોર્મ્યુલા તમને આવડે જ છે. Now angle is the tricky part, everyone. Angle between the vectors is 120 degrees, right? Is this clear, everyone? This is formula for magnitude of resultant. Is this clear? હા, અને એક વસ્તુ છે ને મેં જોઈ છે, ફોર્મ્યુલા છે ને બધાને યાદ હોય, કારણ કે તમને અત્યાર સુધી એવું જ શીખવાડવામાં આવ્યું છે કે ફોર્મ્યુલા યાદ રાખો ને તો सम्स આવડે. But see, now in 11th and 12th things get tough. So for formula, first step, you should also understand the processes. For example, જે ઓલો law હતો, અત્યાર સુધી law તમારે એક્ઝામમાં છાપવા માટે જ આવતા હતા. હવે એવું નહીં થાય. ટ્રાયંગલ લો બધી જગ્યાએ યુઝ થાય, પેરેલલોગ્રામ લો બધી જગ્યાએ યુઝ થાય. સો યુ શુડ નો હાઉ ટુ હેન્ડલ ધ પ્રોસેસ ઓફ ધ લો. ઓકે, એટલે લો સમજાવવો જોઈએ, ખાલી ગોખી નાખવા માટે ન હોય. રાઈટ? ઓકે, so this is it. Now we have to put values, so it's not a big deal here. VBW magnitude only, VBW 25 magnitude, 25 square 625. VWG 10 square 100 plus 2 into 25 into 10. Now cos 120 is probably new for you, okay, at least for biology students. Okay, math students, do you remember value of cos 120 degree? Do you know the value of cos 120 degree? If yes, you can tell me. Then I'm going to teach you a very dirty way, very simple way to find out cos 120 degrees. Math students, do you know what is cos 120 degrees? Okay, very good. Many of you are giving me right answers. Okay. Now there are one or two incorrect answers also. All right, no problem. I think that's enough of it. Now here is for everyone to do it quickly. Look here, I already expect આટલું 10 સ્ટાન્ડર્ડ નું જે આવડવું જ જોઈએ, નો આવડે તો બહુ ખરાબ કહેવાય. કોકવાર ભૂલ થાય તો ચાલે, દર વખતે ખોટું પડે એવું ન ચાલે. You already remember this, right? Okay, I'm expecting that. હવે આનાથી આગળ શું? આનાથી આગળ એંગલ નથી, છે જ ને, right? So suppose you talk about 120 degree, right? Suppose you talk about 150 degree, sorry, 135 degree, 135 degree, and then you talk about 150 degree, and let's say you talk about 180 degrees. એટલે સુધી યાદ રાખો તો ઘણું કામ આવશે ફિઝિક્સમાં. Okay, so you know what you have to do. અહીંયા તો તમને વેલ્યુઝ આવડે જ છે, right? You get these kind of values. Okay, so for sine, all you have to do is you have to just mirror this table. I repeat, you just have to mirror this table. એટલે અહીંયા √3/2 આવે, અહીંયા 1/√2 આવે, અહીંયા 1/2 આવે, અને અહીંયા 0 આવે. સમજી ગયા? Mirrored. Got it? Got it or not? જો આ સેમ જ છે. Okay, now for cos. So આ યાદ રાખવાનો, for sine just mirror, but for cos you have to mirror it and put a minus sign. What do I mean? Let's see. Cos 0 1, cos 30 root 3 by 2, cos 45 1 by root 2, cos 60 1 by 2, and 0. Now you have to mirror it and put a minus sign. સમજ્યા? Like this. આ જો mirror કર નાખ્યો. I hope you can see. Okay, clear? And same rule for tan. Same rule for tan. Okay, આ બેમાં same જ rule. Tan 0 0, 30 1 by root 3, 45 is 1, 60 is root 3, and tan 90 is undefined or infinite. Okay, so like that you take it mirrored, but then you put a minus sign. So minus root 3, minus 1, minus 1 by root 3, and minus 0 is 0. બરાબર ને? તો તમને ખબર જ છે, right? So this is a bigger table, right? Okay, this is a bigger table, right? This helps. બીજા એંગલ્સ હોય તો શું કરવાનું, એ બધું બહુ ટેન્શન ન લો. મોસ્ટલી this is enough for physics, right? બાકી આગળ કેટલું ગમે એટલા એંગલ હોય, but then you don't have to make a table. પછી બીજી ફોર્મ્યુલાઝ યુઝ કરાય, but don't worry about that. આટલું રાખો અત્યારે, જરૂર પડે તો આગળ બીજું શીખવાડીશ. Okay, so this is enough. So please write this table in your notebook, everyone, especially biology students. Math students નહીં લખે તો ચાલશે, પણ તમને આવડવું જોઈએ. આ બધું નહીં આવડે ને તો હું તો હોમવર્ક આપીશ જ મેથ્સનું, પછી લક્ષ્મણ સરને કહીશ કે મેથ્સનું હોમવર્ક આપો એક્સ્ટ્રા, કારણ કે અમને આવડતું નથી. Okay, so let's go back to this sum. All right, I hope everyone has noted the values. I hope everyone has noted the values. All right, shall we go? All right then. So cos 120 degree is minus 1 by 2, right? So let's simplify this. એટલે હવે કઈ કરવાનું નથી. 625 725 2 cancel. આ કેટલું છે? minus 250. Okay, so 625 plus 100 minus 250, right? So that's going to give you your answer, whatever that is. 725 minus 250 કેટલું થશે? 100 ગયા, બીજા 100 ગયા, 500 and 475 square root. એવા હે ને? root of 475. Yes. Okay, so you could simplify it. Either take square root directly or take 25 out of it, right? So as I say, 25 into 16 and 19, yeah. So this is going to be 5 root 19 kilometer per hour. Okay, yes, 21.7 or 21.8 એવું કંઈક આવે. Okay, right? I'm not so sure exactly. કરી જોઉં કે ચાલશે? સમજી ગયા ને? આમ તો કઈ જરૂર નથી હોતી. So this is magnitude. See, but we don't have to find speed. I would warn you, everyone. I would warn you. We don't have to find speed. We have to find velocity, right? So velocity is a vector. It has two things: magnitude and direction. So here also, if you want to find direction, then you have to talk about angles, right? Then you have to talk about angle. So what we could do is, listen to this. We could say this angle is alpha, and we can use that formula, right? Okay, I hope all of you remember. We can use that formula. Tan alpha is equal to b sine theta upon a plus b cos theta. But you just have to be careful here. What you call as a and what you call as b is as follows. When you draw a diagram, okay, and make a resultant, and you say this angle is alpha, so angle between a vector and r vector is alpha. Oh. So here what I have taken as a, this I have taken as a. I hope you understood that. And the other one is b. Clear? Because I'm making angle alpha here, right? Because I'm making angle alpha here, that's why That's why this is going to be over here, right? Okay. So let's take this as A and this as B. So again, VBW is A, VBW is A, and the other one is B. I hope you would have understood the use of formula, right? VBW is A and the other one is B, right? So let's put values. VWG is 10 sine theta. Sine theta is 120 degrees. Don't forget that. Divided by VBW is once again 25 and VWG is 10 cos 120 degrees. So sine 120 degree from the table is root 3 by 2. 25 plus cos 120 is minus 1 by 2. Okay, I hope you understood what I did, right? Cos 120 degree is minus 1 by 2. So this is what we get. Right? આટલું તો maths જ હતું after using the formula. So we have got tan alpha is root 3 by 4. So if we put root 3's value like 1.73 divided by 4, so that is going to be 0.4, and then you have a 3, and then you have a 2, and you have a 5. So 0.4325. Okay. Right? So this is what we have got. હવે alpha find કરવાનું છે. See, we have got the value. We have got a value of tan alpha. Now we have to find alpha, right? Angle. We have to find the angle. So this is once again those times where the table of natural tangents is to be used. Okay. Like I said, we need it. Okay. So please buy it as soon as possible. Okay. આવી રીતે ગમે ત્યાં એંગલ ફાઇન્ડ કરવાના હોય ને તો જરૂર પડે છે. ઓકે. અને 12th માં આવશે એક વખત લઈ લો એ 5-10 રૂપિયાનું કંઈક આવે છે, right? Or like I said, you can print it off the internet. Okay, that helps if you don't want to go to the market and buy it, right? બે પેજ જ હોય, કંઈ વધુ ન હોય. Rohan, I will teach it how to find from table, but first of all I want all of you to know. I want everyone to get the table. એટલે મારે પાછું બે 3 વાર શીખવાડવું ન પડે. ઓકે, બહુ સિમ્પલ જ છે, just like seeing log and anti-log. Okay, even easier actually. Log anti-log તો તોય complicated છે. This one is very simple, right? How many of you have the table? Let me just vote. If you have the table, can you just raise your hand? If you have the table, can you please raise your hand? Okay, about 10 people have it, right? The others don't. So there are many that don't have. So please, people, please buy it at the earliest, right? Sometime in next week, I will teach you how to find it. Okay, એક વીકમાં તો ગમે એમ બધા લઈ જ આવજો હવે કઈ, બરાબર? So let's fix it next Monday. Right, next Monday. If Monday is a holiday, Tuesday. So don't ask what if Monday is a holiday, right? Okay, so next Monday is the plan. If we can't do it on next Monday, next Tuesday, right? So I'm giving you a time of 6 days or so, right? Anyways, here I will just find it, right? I'll just find it from the calculator. Tan alpha is 0.4325, and okay, so it gives me 23.4 degrees. 23.4 degrees. All right, so that's what we have got. So now we have to write this answer. Khali avu no lakhai. We have to write it in words. So you could say resultant velocity is 21.7 kilometer per hour. અહીંયા લખજો with respect to ground. Okay, resultant velocity is 21.7 kilometer per hour at angle 23.4 degree east of north. Yes, the final conclusion, right? See, why is it east of north? Let's just go and revisit that diagram. So east of north means, first of all, you look towards north. Okay, and from there this angle is 23.4 degree, correct? So from there you go towards east side. Here is where you have the resultant. I hope you understood that, right? Rough sketch again. So this is 23.4. So we are saying 23.4 degree east of north or east from north. Okay, right? So that's the final answer of this question. All right, so I hope you got it, right? બીજી મેથડ છે કોમ્પોનેન્ટ્સ વાળી. તો એમાં તમે કોમ્પોનેન્ટ્સ લો બેયના, એકના બહુ ઈઝી છે. VBW is very easy. It is simply 25 J caret, right? અને જે VWG છે એના પછી કોમ્પોનેન્ટ્સ લેવા પડે. So it will be something I caret and something J caret, right? Yes, Raj. Okay, looks like you have done it like that. Okay, and then you just add them, right? So after you add, you get VBG, right? You get VBG is VBW plus VWG, right? પછી પાછું I caret J caret form આવશે. Then take magnitude, and if you want you can find the angle also. So that's it, right? Okay, so that's how you do it. Fine. Okay, let's go to exercise, right? I'm sure there would be some question like this in the exercise also. Relate 4.6 is done. Yeah, 4.7 is done. Yes, going to the exercise, question number 12. Okay, 12 is homework. In exercise, question number 12 is homework. All right, everyone, in case you didn't notice, in exercise, question number 12 is homework. Okay, it's just like the rain questions that we did yesterday. So hopefully now you'll be able to do it on your own, right? Now let's solve 13. Okay, now we are going to solve question 13. Okay, now we are doing question 13. Here is the question, half of it at least, and then the remaining. You please start reading it and try to imagine and try to draw what's going on. Okay. Yes, Raj, some question? Okay. So now let's start. It is given that a man can swim with speed of 4 km per hour in still water. So basically his swimming capacity is given. The man can swim with respect to water, of course. Okay, sorry, speed, not velocity, right? This is given. VMW is 4 km per hour, right? Velocity, sorry, speed of man with respect to water. Okay, that's swimming speed, of course. So how long does he take to cross a river 1 kilometer wide if the river flows steadily at 3 km per hour? Okay, so that is speed of river. I repeat, speed of river or water. River is flowing, actually water is flowing. So speed of water with respect to ground. Okay, when we say there is audio, I'm sure all of you can hear, right? You can hear everyone. Can you all hear me clearly? Okay, Vedant, there's some problem on your side. So VWG, that is speed of water with respect to ground, is 3 kilometer per hour, right? Okay, and now comes the important sentence. He makes his strokes normal to the river current. Now this is important sentence to understand. So let's draw a diagram. It says that, suppose here is the river, suppose here is the river that flows in this direction. So that immediately gives us that the velocity of river with respect to ground is in this direction. All right, okay, we are saying that the velocity of river with respect to ground, or water with respect to ground, is in this direction. Yes, Vedant, no problem, rejoin. Okay, so what is the man trying to do? The man is trying to is making his strokes normal to river current. Normal means perpendicular. In case you don't know that, the meaning of the word normal is perpendicular. Please write it if you don't know the meaning. Okay, so what is the man doing? The man is trying to swim perpendicular to river current. Okay, I repeat, the man is trying to swim perpendicular to river current. So this is very natural experience. I'm sure you all would realize, if water is flowing like this and you try to swim like this, okay, perpendicular to it, so actually with respect to ground you would go there. You understand this? Water will drag you. You understand this? Water will drag you. Do you agree with this? If you try to swim like this, the water will drag you and you will go sideways. Okay, yes, very few said yes. Is it clear to everyone that water drags you? If water is flowing like this and you try to swim like this, you won't actually go there, right? You will actually go here. Okay, fine. Okay, fine. Yeah, so let's write all of this in language of physics, okay, with proper vectors and everything. So again, VWG is, let's say, towards the right side, means water is flowing sort of, yes, Rohan. Water is flowing towards the right hand side. So VWG is towards the right hand side with respect to ground. Okay. So water is going like that. And this man is trying to swim like that. So he is trying to make his strokes. He is trying to swim in this direction with respect to water. Again. Okay. But actually that is with respect to ground. When someone standing over here, okay, the cheerleader standing on the ground, they will not see the man go like that. They will actually see the man go like that, right here. So with respect to ground, the velocity of man would be like this. Is this clear? Is this velocity diagram clear? Diagram clear, everyone? Okay, diagram સમજાઈ ગયો તો બધું આવડી જશે. No worries at all, right? So let's write one or two supporting equations. So first of all, I'll write the equation of relative velocity. So velocity of man with respect to water by the relative velocity equation should be equal to Vmg minus Vwg, right? So now if I if I would see what is VMG, if I would see what is VMG, right? Simple, putting this on that side. So VMW vector plus VWG vector, right? So you can once again see that this is addition. You can once again see that this is addition of vectors, and that's why once again we are seeing the parallelogram law come into action, isn't it? Everyone saw that the parallelogram law is coming into action here, right? Addition of this and this is this resultant. Okay, આ ટ્રાયંગલ લો થી થાય. તમને એમ થશે કે કેમ તમે ટ્રાયંગલ લો નથી કરતા, કરાય. ટ્રાયંગલ લો થી કરો તો આવું દેખાશે. VWG is here, then I'll have to draw VMW from here, right? Because you have to draw the second vector from the head of first, and now you join the tail of first with the head of last. તો જો સેમ જ આવ્યું ને, આ દેખાય? Okay, I hope you remember I told you that actually the triangle law and parallelogram law are same. They always give the same result. Okay, so this is it, right? Now we have to find, let's see what do we have to get actually. How far does the, no, okay, there's something else. How long does he take to cross a river? So we have to find time, right? How long? So we have to find time. Okay, a triangle bani gyu barabar. Now we have to find how much time will he take to cross the river, right? That is to go from have a physical diagram where we actually draw where the person starts and where he ends up. So let's say he starts from here, and now he's actually going here. So let's say the person goes from A to B. Okay, right? Trying to go there, but not going there, going in this direction. So we have to find how much time it takes for this person to go from A to B, right? Now, here you can make it very easy or very complicated. જો સમજવામાં સહેજ એવી ભૂલ થઈ ગઈ તો confused થઈ જશો. So just be little bit careful. I'm saying that crossing the river should be related to the vertical component of velocity in this diagram. Crossing the river is related to moving vertically in this diagram, in this way, correct? Not horizontal. Do you agree? How much time it takes to cross the river? Cross the river no matlab શું થાય? Going from one bank to another bank. So that is related to this vertical. If you talk about it in form of axis, then I'm saying that crossing the river is related to y axis, not to x axis. Do you understand that first of all? Okay, I'm getting a big, right? So that's why here, if you want to find time to cross the river, so time to cross the river t. Okay, if you want to find t, see here, this is a very simple case. Here velocity is not changing at all, everything is constant, right? So you could just say this is equal to delta y, because I just said y, so I'm writing delta y. Okay, delta y divided by velocity is y component. Clear? This is actually the same as delta y equal to v0y t plus half ay t square. પણ એટલું બધું લાંબુ કરવાની જરૂર નથી, because there is no acceleration. So you get this and just divide this on that side, right? Okay, let's keep it very simple. અચ્છા, delta y એટલે શું? Delta y means here, this one, right? So that is width of river, isn't it? Delta y means width of river. Okay, so width of river, I think we are given in the question. Width of river, width of river 1 kilometer. Yes, Okay, divided by vy, that is y component of velocity. Now if you have a look, if you have a look at this triangle, the man is actually having this velocity with respect to ground. So do you agree that this is the y component of velocity and this is the x component of velocity? Yes or no? Okay, right. દર વખતે આટલું સિમ્પલ ન આવે. આ બહુ જ સિમ્પલ ક્વેશ્ચન છે. So vy is vmw, right? Vy is vmw. So therefore t is equal to 1 divided by 4 in hours, right? Can't get time hours mouse because distance is in kilometer. This distance is in kilometer and this value is 4 kilometer per hour. So the time is in hour. 1 by 4 hour, right? 1 by 4 hour. So 1 by 4 hour means 60 by 4 minutes. That is 15 minutes if you want. Okay, right? So that's your answer. It will take 15 minutes to go from one bank to the other bank. Okay. Now there's one more question. How far down does the river he go? Down એટલે downstream. Tens માં આવતું જ હશે ને downstream upstream. Right? So that means by the time this person is able to swim to the other bank, how much downstream does he go? Downstream, that is, he was actually trying to go there but went here. So this is the answer of the part 2, correct? I repeat, I'll just draw it very quickly again over here. He was trying to go from this point A to the point C, but because of water flow he ends up going over there. So how much downstream did he got dragged? Okay, so this is our answer of part 2, right? Okay, so that is delta x, isn't it? Right, I'm sure you all understand that this is delta y and that is delta x, if you find it like that. So we have to find delta x and we know the time. In 15 minutes, how much will he get dragged downstream? Okay, so we can write, so downstream distance covered. Okay, so how much did he get dragged downstream? Is delta x, and that should be equal to, which is the velocity in x direction, which is the velocity component in x direction? Have a look. It is clearly vwg, right? So we can just put vwg over there, right? Okay, and multiply it by time. Once again, actually it's supposed to be like this, but because acceleration is not there in this whole problem, we can just ignore this, so we get this, right? Okay, right? 1 by 4, we should write 1 by 4 because this is in kilometer per hour and this is in hour. 1 by 4 hour, right? So finally this becomes 3 by 4 kilometer. I hope everyone got that, right? Okay, others clear? Okay, now related to this, very kind of problem, you should understand two facts. Number one, the one that we have solved here, is actually the shortest time to cross the river in shortest time. It is necessary that VMW is perpendicular to VWG, right? to cross the river in shortest time, VMW vector should be perpendicular to VWG vector. That's what we have done, right? એટલે shortest time માં કેવું થાય ખબર છે? Again, he's at point A and he should try to go, he should try, I repeat, try. So VMW will be in this direction. But because of the water flow in this direction, the water will drag that person and take that person over there. So to cross the river in shortest time, the person should make strokes perpendicular like this. જેવું આ question માં હતું. Okay, so that what will happen is all his effort will be in this direction to cross the river. Okay, but what happens as a result is that the water drags the person forward downstream and the person ends up over there. So this is a very strange case. Gracie, in answer you can write, but you can't put it here. Okay, here you can't put 15 because units have to match, otherwise the calculation is wrong. Okay, so what happens is that the person is covering or crossing the river in shortest time, but this is not the shortest distance. I hope you realize that the person crosses from A to B. This is definitely not the shortest distance, right? Okay, and this shortest time, this minimum time or the shortest time, is actually going to be equal to width of river D, suppose, divided by VMW. This is always true. આ ગોખવું હોય તો તમે ગોખી શકો. This is always true. I hope you have understood the reason also. We just did that here, right? Okay, so to cross the river in shortest time, this is what happens. Now second one, to cross the river in shortest distance. To cross the river in shortest distance, what does that mean? That actually means reaching the point exactly opposite, reaching the point exactly opposite to starting point. Okay, so that is a different case. Okay, that's a different case. That case looks like this. So person, let's say, starts from here and actually goes to C. Actually, truly speaking, okay, right? Is this clear? The person is actually able to swim to that point. એવું ક્યારે થાય? Is that the river, suppose, is still flowing towards this side. Okay, see, this is interesting. So if the river is flowing towards the right side and the person still wants to go from point A to point C, then do you realize that the person should try to swim in this direction? હજી કંઈ ડ્રો ન કરતા, હું પછી તમને લખાવજો બરાબર. Do you realize that the person should try to swim in this direction? So what will happen is the person will try to swim like that, but the water will drag that person and અહીંયા લઈ આવશે. See, this is a very smart move if you understand what I'm saying. The person should try to swim like that, but water will drag that person and bring it opposite, right? So here the triangle will be very interesting. See, here the triangle will actually be like this. This will be VMW, means the person is trying to swim there, trying to swim in VMW's direction, obviously. એટલે સ્વિમિંગ એ ડાયરેક્શનમાં કરે, એટલે માણસ છે ને આમ દેખાતો હોય તમને સ્વિમ કરતો, પણ તોય છે ને આમ હોયો જાય. I hope you understood that, right? It will appear as if the person is swinging his arms like this and VWG is over here. એટલે આવી રીતે triangle law પૂરો થયો. Let me tell you how. Earlier we have written that VMW, થોડુંક explanation આપું. VMW is equal to VMG minus VWG. Put this term on that side. So we get VMG vector is equal to VMW vector plus VWG vector. So now we are using triangle law. Have a look. Draw the first vector. Okay, done. First vector. from the head of first. Draw the second vector. Okay, done. And now join the tail of first with the head of last. Okay, right? I hope you understood how we added this. So if this person does this, then the person will be able to cross the river in shortest distance. That is, the person will reach the point exactly opposite to starting point. A is the starting point, right? Okay, right? So such a question can also be asked, that at what angle with maybe this should the person try to swim. Then we can find that angle very easily using tan theta is equal to VWG divided by we can find it easily using sin theta is equal to VWG upon VMW. કારણ કે આ નો ખબર હોય, we would know VMW and we would know VWG, right? Generally we would know these two. So if we know these two, we should use sin theta, we should not use tan theta. I hope that makes sense, right? So if you do it like this, then you can find the angle at which the person should swim, so that the person will reach a point exactly opposite. Ankita, obviously time taken by man is more in case 2, because like I said, this is the shortest time. The first case is actually the shortest time, not the shortest distance. The second case is the shortest distance, but not the least time, not the smallest time, right? This second case will take more time, right? Okay, so in fact you can change this question, to do that. Okay, I'm writing a question, you take a screenshot, this is your homework question. I will not send it separately. Okay, right? So in exercise question 4 point કયો હતો આ 9 no sorry 13. Okay, in exercise question 4.13, if the person wants to reach a point exactly opposite of his starting point, okay, then at what angle with river flow, see with river flow, be careful, with river flow, બરાબર? એટલે આ એંગલ નથી પૂછ્યો, આ થીટા નથી પૂછ્યો. This is not with river flow, this is with river flow. All right, so be careful to add 90 degree. So then at what angle with river flow should he make his strokes? Okay, so this is one question. And related to this, how much time will he take actually, how much time will he take to cross the river? Okay, in this case, okay. All right, take a screenshot everyone, and then we'll end this class. Okay, I'm giving you 1 minute to take a screenshot. I'll just end the meeting, right? I'll not explain anything else now. Okay, done, everybody. Goodbye, everyone.